Welcome to Machine Learning for Doctors. Google Drive and then click New, go to More, connect more apps. Let's see, Colab, connect Colab, okay, hit OK. Let's just close it. Now go to New again, More, Colab. As you can see, this opens an IPython notebook. You can change the default name by saying first experiment. Okay, and this is where you write your code. Now you go to Machine Learning for Doctors. Okay, here you go down, and let's go to the part 2 here, and then let's first download the database. So click here on the Google Drive here. Alright, now we'll download it. Click download. Okay, so save it to desktop, and let's save it as, yeah, that is, let's click here to download the, okay, there we go. Sorry about that. Download the CSV file to your desktop. That'll be wisconsinbreastcancer.csv. Should be onto your desktop. Hit save. Okay. Now we already downloaded the IPython notebook also, so let's go and open the IPython notebook. So you go here, File, Open, Upload Notebook. Hit that, select a file from your computer, and let's go to desktop. So machine learning tutorial, you click that, open it. Alright, so that notebook is being loaded. As you can see, you have a description of the notebook on the top, and anything that has a hashtag, it means that it's a comment. So the first line is import pandas as PD. This helps us to this pandas helps us to load data or CSV file or Excel sheets into our database. So for this to work, you had to, for each cell to work, you had to click on that cell, press Shift Enter or Shift Return in Mac, and as you can see, it starts working here. That's first time, it may take some time, and then it'll be fine. Okay, so we imported pandas. Now we are going to import the CSV file or our data file using this code block. So again, you hit Shift Enter. So choose file, go to your desktop and get the Wisconsin breast cancer CSV file, which we have downloaded before. Hit open. Okay, so as you have seen, user uploaded file Wisconsin breast cancer CSV. Now we are going to import that CSV file into this notebook, and this is done by this code here. You just pass the name of that file. Well, you don't have to understand all these steps at this point. I would say just go through this and then you get a sense of it, and if you want to learn more about it, you can go to a Python tutorial and learn more about it. So I'm going to hit Shift Enter, so it's loaded into our database. Now we are going to display the first 5 rows of the database to see what we imported. So let's hit Shift Enter again. As you can see, there is an ID field, there is thickness, size, shape, adhesion, and finally class. This is the one which says whether it's cancer or not. 0 means it's benign and 1 means it's cancer. Now the next line of code shows us how many rows and columns are there in the database. So 699 entries with 11 columns. Okay, now we're going to see if there is any missing values in any fields. That's done by this code data.isNull, and that will return whether there is any missing data. Okay, and as you can see here, the nuclei label or the column has 16 missing values. Now in this next line we are going to drop any missing values here, so click Shift Enter. Okay, so we dropped all those missing values using this. Now we are going to create a feature set which will have all the features that we want to train the model on. That will include the thickness, the size, shape, adhesion, nucleoli, and mitosis. And we are going to store just these variables into X. Okay, let's do that now. Alright, and let's see what X has. So as you can see, we took off the ID part, which we don't need, and we don't have the class column here, which is the prediction that we want to create. So we got all the features here. Now we are going to store the class, which is whether it's cancer or not, into variable Y. Alright, we got that. Now we are going to do the classification. So first we need to import certain packages to do that, and most of the packages that we're going to use is inside a package called sklearn, which is used for machine learning. Okay, and then we are also going to import train test split. So this helps us to divide the whole data into a training set and a testing set. So the whole idea behind this is we are going to create a model using the training data, and then we are going to use that model to test the testing data and find out the accuracy of the model. Okay, so let's do that. Alright, so well, don't worry about this. Now we are going to train the logistic regression model. So we are going to import that module from sklearn, and then we are going to assign the logistic regression to a variable logreg, and this is the most important step. So we are going to fit the model. This is how we train it. So we are going to say logreg.fit xtrain, ytrain. So what we're trying to say is, well, xtrain is the features that we have, and ytrain is the output or the label that we are trying to predict. So the computer has to find a mathematical model to connect the xtrain features to the ytrain labels. So that will be done here. Let's do that. Well, it's like pretty fast. In like few seconds the computer created the model. Now we are going to make predictions from the testing set. So we are going to use that logreg model that we just created, use the predict function, and use it on the X test, which is the testing set we created, and we're going to store those results into Y prediction class. Okay, let's do that. Now we created all these things, so how good is our model? Okay, so again, that's an easy step. We import metrics function from the sklearn library, and then we print the accuracy score. So for that to work, you had to actually pass the actual labels, which will be the Y test, and the predicted labels, which will be the Y prediction class. And the metrics accuracy score will calculate the accuracy based on the actual values and the predicted values. Let's see. So turned out to be 92.9%, which is not bad. Okay. Now, how can we predict? Well, how can we say that our model is better than randomly guessing that all the cytology results were benign? So that can be done, well, pretty much easily in this module. So what we do here is try and see how many benign results are there in the test set. So there are 107 benign results in the test set, which is much higher than what we have in malignancy. Now, let's see the percentage of zeros in the benigns in the testing series, and this will be the accuracy of a dumb model if we predicted 0 all the time, meaning like if we predicted benign all the time. So that turns out to be 62.57. So as you can see, our model in few seconds we're able to predict a dumb model, like if we're going to say, hey, most of the thyroid or breast biopsies are going to be benign, so it turns out our model has better prediction accuracy than just saying that most of them are benign. Alright, now let's see the positive predictive value, negative predictive value, sensitivity and specificity. Okay, let's first do that with creating a confusion matrix, which is easy. You just go to matrix.confusion-matrix and pass on the actual value and the predicted value. So let's see, we got that here. So let's see what this means. So when the model actually predicted 0, it was actually 0 in 103 cases. When it actually predicted 1, actually it was 0 in 4 cases. So on and so forth. Now let's find out the true positive value, true negative, false positive, and false negative to create all those statistical results that we want. Okay, now let's find the sensitivity of our logistic model, which is defined as true positives divided by true positives by false negative, and that is 87.5, which is not bad for, we didn't do any feature engineering or anything like that. Just like out of the box, we got 87.5% sensitivity. Now let's calculate the specificity, that is true negative divided by true negative by plus false positive, and that's pretty impressive. So it's very specific, 96.2%. And now in the next line, let's calculate the false positive rate. So when it's saying it's positive, what are the chances that it's actually negative? So let's do that. So the false positive rate is pretty good, 3.7%. And next line, we calculate the positive predictive value. So what are the chances that if the model comes back and says that this is cancer, in how many percentage of the cases will this actually be cancer? Okay, so that's 93.3%, not bad. Now let's also calculate the negative predictive value. This is where the model predicts a benign label for the data and how true this is. So 92.7% of the time, if it's a negative value, it's going to be actually negative.